We're solving problem 24 from the 2021 AMC 12A. Semicircle gamma has diameter AB of length 14. Circle omega lies tangent to AB at point P and intersects gamma at points Q and R. If QR is 3√3 and angle QPR is 60 degrees, then the area of triangle PQR is equals A root B over C, where A and C are relatively prime positive integers, and B is a positive integer not divisible by the square of any prime. What is A plus B plus C? So this is a drawing of what it's depicting here, and this semicircle, we call this point O, and the center of this smaller circle X, but in reality this smaller circle is circle omega, and this semicircle is gamma. We are given that the radius is equal to 7 for this semicircle, so that's going to be important and we're going to need that later. But they obviously gave us our the angle QPR for a reason. This is 60 degrees. So we want to see if we can do anything with it. And actually we can. If we solve for the length XP by using the extended law of sines, this is QR over 2 sine of the angle QPR. QR is 3√3, and well, since this is just 60, sine of 60 degrees is √3 over 2. So this is 2 times √3 over 2, which is 3. And now we realize that M is the midpoint of this segment QR. So we can say that RM, the segments RM and MQ, they're equal because M is the midpoint. This is QR over 2, or 3√3 over 2. Well, now what we can do is, well, if we just draw a line from R to O, this point, we can use the Pythagorean theorem on triangle ORM to solve for the length OM and then find XM and OX in all these segments, because that would help us. So we get that OM, segment OM is equal, I'm going to write it here. Segment OM is simply the square root of OR squared, the diagonal, minus this side, MR squared. We actually have all these values because, well, point R point R is tangent to the semicircle gamma, and since it's tangent, you can, if you draw an imaginary line from R to O, that's basically just the radius, because the radius is the definition of a radius is on a circle. When you draw an arc that extends to the edge of the circle, that's always going to be that exact length. So we know that the radius is 7 since the diameter is 14. So this is 7 squared, and then MR, we know that as that is simply 3√3 over 2 from this statement here. So this is 3√3 over 2 squared. Take the square root of that. When you solve this, you will get that OM is 13 halves. You can then solve for OX this way. OX is simply OM minus XM. So you're taking the longer segment and subtracting the smaller one to get the desired segment. This is 10 halves or 5. Now we have this, right? We can also draw up a ratio. So ratio of XP to OX, well, this is going to be XP to OX. is going to be 3/5. So with this property, you can now say that PD, the length, is 9/5 from this, because we know of that is true. So we can then solve for the length PC. PC is the base of this right triangle that we drew from these dotted lines. That's PD plus DC. This is 9/5 plus, well, what is DC? Well, from this, we know that this is equal to segment XM. Basically, it's not equal, but it's above at the same region. This is going to be the value 3/2 in this case. Because we know that XM is also 3/2, since when you subtract 3/2 from 13/2, that gets 10/2 or 5. So this is 33/10. We can now solve for the area of this triangle. The area is 1/2 base height squared. So this is 33/10. I mean, not squared, just base height. And then the height is QR, or 3√3. The area is 99√3 over 20 when you evaluate all of this. The problem wants the sum of all these numbers. So our answer for this problem is 99 plus 3 plus 20, or simply 122. That is our answer for this problem.